Okay, so before we continue practicing more with the mx plus b form of a line, we're going to revisit sequences from last week. And this time we're not going to really focus on different kinds of patterns, except in terms of their bald form. In other words, their sequential, their sequence form. So we just got sequences straight up today. We don't have like tiles attached to them or any other kind of pattern pictures. It's just the straight numbers, and that's what you guys just worked with. So if you're watching the video, the first thing you want to do is look at these four sequences and try to write down, do they have a common difference? In other words, do they add or subtract something every time? Or do they have a common ratio? Are they multiplying or dividing each time? And try to write down what each sequence is doing, and then come back, unpause the video, and look at the formal mathematics of sequences. So there's two kinds of sequences in here. There's of course many other kinds of patterns, many other kinds of sequences in nature. But the kinds that we're working with in this unit are just two. They're arithmetic and geometric. If you know arithmetic and geometric really well, including the mx plus b forms and stuff, by the end of this year you're good to go. You don't need to know that many functions coming out of Algebra 1, just a couple. So this is the arithmetic form of a sequence. It actually relates really closely to y equals mx plus b, but it looks very different, of course, right? Once you understand it really well, it's like, oh, it's just mx plus b. This needs to be memorized. Then you have something that's for the geometric form of a sequence. It's almost exactly the same. If you look at them, they're very similar, except one has an R in it, one has a D in it. If you have one memorized and you understand the concept, there's really just one thing to memorize, honestly. But you can memorize them separately too if you like. So, can you guys help me out? This sequence, does it have a common difference? Does it have a common ratio? And I'll write, I better define what these things are. D here is the common difference, right? So here D is what we call the common difference. A sub 1, I think we've used this notation a little bit. This is the first term. And I ran out of space, so I'm just going to say this one. A sub n is the nth term, or wherever you are right now. You've said it that way before. So over here, we also have the first term, but we don't have a D, we have an R. And R is the, what do you guys think? Yeah, R is the common ratio that I was asking you guys to find. So I kind of mixed them up now. We're going to write down what the common ratio or difference is for each one, and then we're going to write down the actual sequence form, the explicit form. So, does this one have a common ratio or common difference? What'd you guys get?
Difference.
Difference? What's it actually doing?
Subtract.
Going down by 5 every time, I agree. You guys, down by 5, down by 5, down by 5. Let's just write that down. Subtracting 5, 5. Subtracting 5 each time, each term. So now we're going to go ahead and write down the actual explicit thing. So that means D is negative 5. So that means the sequence A sub n is, what's the first term? Do we know it? 2. That's the launch pad. That's kind of like the y-intercept on your line. 2, and then we go, the formula says plus n minus 1. And then we stick in our common difference. So that is the explicit form of that sequence. If you distribute, you'll get mx plus b. So if you distribute, you're going to get that form of a line. So let's see, we're going to get 2 plus, not plus, let me just eraser here. That times that is negative 5n. That times that is positive 5. Are there any like terms, guys, to put together? There's that sequence. If we were to graph that sequence, it would be dots on the line y equals mx plus b. So this is really mx plus b form. It's just the discrete version not the continuous version. You guys remember us talking about discrete, continuous? Discrete is when you just have a bunch of dots. Continuous is the whole thing, the whole line, okay? All right, so what do you guys think on this one? Is this guy a common ratio, common difference? What's going on? It's a ratio. What is the ratio? Times 3 is right, yeah. If you go times 3 times 2, that's 6. 6 times 3 is 18. 18 times 3 is 54. And you might need your calculator, but multiply by 3 and you get 162. So this has an R of 3. What's its first term? 2. And now we can use the formula. So we're going to say the explicit form a sub n for any nth term is a sub 1 times r is 3, the n minus 1. So there's that 3 that you were trying to ask me about earlier. It's a little more complicated than just 3 to the x, so you see what I mean. So that is the explicit form of that sequence. Biggest thing on this one, common difference, common ratio?
Difference.
Yep, this is subtracting or adding.
Subtract.
Oh, it's like almost the same as the last one, so it's like negative 0.5 this time, right? So we could say a sub n is first term plus n minus 1 times negative 0.5. So I'm going to simplify by distributing. So it's going to be up plus. I keep wanting to say plus on those. That times that is minus 0.5n. That times that is plus 0.5. These are like terms, so that's 2.7 minus 0.5n. And if just another link from what we were working on last week, when you do mx plus b, when you graph lines, did we always look at the y-intercept? Did we look at the first term in the pattern, the second term, the third term? Where did we look to find the y-intercept, the b? It wasn't the first, second, or third, it was the 0 term. The 0 term back here would be what? And there it is. The 0 term back here would be what? 7, and there it is. So all the stuff we've been doing, it all works well together. It's all the same stuff, just a question of how you organize it. Okay. So what do you guys think on this one? Was it common ratio or common difference? Ratio. I think it's times. I think it's times 3 again, isn't it? Negative 15 times 3 is negative 45. Times 3 is going to be a negative 135. Yeah, this was 3 again. So very similar to the last one. So it's going to be first term times ratio to the power of n minus 1. There you go. That's it. If you plug in 3 for n, you'll get that. If you plug in 4 for n, you'll get that. If you plug in 5 for n, you'll get the next one. If you plug in 10 for n, you'll get the 110 down. It's the explicit form of a sequence. Just for grins, let's also go over what you guys were a lot more comfortable with. Let's go over the recursive form on just a couple of these again, because I think your handout for day 9 is going to look like that. So let's see, this is the explicit form. What's happening each time? We're, again, subtracting 5. So the recursive form on these, I'm going to do them all in purple. So recursive on this one's going to be a sub n equals a sub n minus 1, the thing before, now equals previous, and now I do need you to write this the right way. So you need to write this like this. That says a sub n is the thing before it. Can we go minus 5 on this one? That's it. Minus 5. So this guy will be that guy minus 5. This guy will be that guy minus 5. Let's do it on this one. So a sub n is going to be the thing before it. And what do we do with the thing before it on this one? Times 3. This guy is the thing before it, minus 0.5. This guy is the thing before it, times 3. For recursive, though, you always have to say what the starting spot is. You've always got to say the first thing is 2. The first thing is 2. The first thing is 2.2. The first thing is negative 15. If you don't have a starting spot with recursive, you can't get anywhere because the current term always relies on the one before it, so you have to have a place to start from. Okay, so that's the full-blown deal for recursive and explicit for arithmetic and geometric sequences. I'll see you next time.
Love you.